Change of subject of the formula, lesson 2. We shall be looking at equations that involve squares and square roots. Example 1, f equals to mv squared over r. Let's make v the subject of the formula. Okay, let's consider this equation. We are going to make v the subject of formula in this equation. So first of all, we'll try to bring this r to this side, then m to this side, so that v can be alone. So what do we do to remove r? Since r is dividing this number, we are going to apply the inverse operation of division, which is multiplication. So we are going to multiply both sides of the equation by r. So we are going to have f times r equals to m v squared all over r times r. All right, so r will cancel r, and we're going to have f r equals to m v squared. So we have succeeded to move r to this side. So remaining m, since m is multiplying v squared, and I hope you know that mv squared is the same thing as m times v squared. So whenever you see two variables together like this, know that there is a multiplication in between them. They are multiplying one another. And so because of that, we are going to apply the inverse of multiplication, which is division. So we are going to divide both sides by m in order to eliminate m and bring it to this side. So divide here by m and divide here by m. M will cancel m. We are going to have f r all over m equals to v squared. Okay, now our main problem is, how do we get this square? Since we are making v the subject of formula, not v squared. So definitely we want to eliminate this square from this v to this other side. So we are going to find what is the inverse operation of square. The inverse operation of square is square root. So we are going to apply square root to this, and we're also going to apply square root to this, because whatever you do to this side of the equation, you are going to do to this side. Okay, so if we square root the variable with a square, the square root is going to cancel the square. So we are going to now have square root of f r over m equals to v. Now let me explain this. For instance, I have square root of 2 square. Okay, remember that 2 square is 4. Is that okay? And the square root of 4 is 2. So therefore you can see that the square root of 2 square is 2. The difference between this and this is that this is gone and this is gone. So that is what we did here. Square root cancels square. So that is what we did to have v. Of course, this equation can now be written as v equals to square root f r over m. So we have succeeded to make v the subject of the formula. Example 2, v equals to square root of 2m over r. Let's make r the subject of the formula. Okay, we have this equation, and we want to make r the subject of formula. So what do we do? The first step is to see how we can eliminate this square root. Okay, and what is the inverse operation of square root? It is square. So we are going to square both sides of the equation. So we are going to square v, and we are going to square this entire equation. So we have something like this. Okay, so this will give us v squared, and now this square is going to cancel out this square root. All right, so we are going to have 2gm over r. Is that okay? You know, what I did was that supposing I have something like this and I square it, the square is going to cancel out the square root and I'm going to have x. So that is what I did here. Okay, so we have been able to shift this square root over to this side. It's now square, no longer square root. Now let's see how we can push other variables to the other side. Now there are two methods to do this. The first step is to move the r to this side. So what do? R is dividing these variables 2gm. So the inverse of division is multiplication. So we're going to multiply both sides by r. We're going to have v squared times r equals to 2gm over r times r. All right. Okay. So since this is dividing all of this will cancel out this. We're going to have v squared r equals to 2gm. Okay. Remember that we want to make r the subject of formula. So r is already here. What is left is this v squared. How do we bring this v squared over to this place? Now remember that this v squared r is something as v squared times r, which is multiplication. So we are going to apply the inverse of multiplication, which is division. So we divide both sides by v squared. So v squared cancel v squared. We are going to have r equals to 2gm over v squared. So we have been able to make r the subject of this formula. Okay, let's go to the method 2. First of all, we still have to remove the square root by squaring both sides. We have done that before. This will give you v squared, and this square will cancel the square root, remaining 2gm over r. Okay, from here we can also decide to move this 2gm over to this side so that we can have only r remaining here. How do we do that? Since this is multiplication, we are going to apply the inverse of multiplication, which is division. We are going to divide both sides by 2gm. And now we could have done this one after the other, maybe 2, then after that g and m, but we can take 3 of them at the same time. What I mean is that we can now divide, we can now divide both sides by 2gm. All right, so this will be 2gm. So 2gm will cancel 2gm, and we're going to have v squared all over 2gm equals to, what will remain here when you have cancelled that 2gm will be 1 all over. The next step is to reverse this equation, which can be written as, by bringing the denominator up, we're going to have 2gm over v squared. R will go up, r over 1. Is that okay? Which is the same thing as 2gm over v squared equals to r, because any number divided by 1 is the same as that number. Just like saying 2 over 1 is the same thing as 2. So that is what we did here. Of course, we can now rewrite this equation as r equals to 2gm over v squared. Is that okay? Yes. Or if we don't want to do it that way, we can, from here, bring 1 over r to this side and bring v squared over 2gm. The same thing applies. We have to turn the equation upside down. So we're going to have r over 1 equals to 2gm over v squared. Alright, so we now have r equals to 2gm over v squared. So we have succeeded to make r the subject of the formula. Example 3, a equals to pi r square root of h squared plus r. Let's make h the subject of the formula. Let's look at this more complex equation. We want to make h the subject of formula. Okay, so we begin by working on the square root. So the inverse operation of square root is square, so we're going to square both sides. So we have a square equals to, we put all of this in brackets, so we have pi r square root h square plus r bracket close square. So this will be a square equals to, now this square is going to work on this as independent variables. So we have pi square r square, but when it comes to h square plus r, because this square root is housing both of them, so the square is going to work on them at once. So this square will cancel the square root. Then we are going to have, remember we are going to put them in brackets since they are together. We have h square plus r bracket close. I hope that is understood. So we have made the equation simpler. Okay, there are two methods from here, so let's see whether we can choose one method. First of all, we want to see how we can eliminate this pi squared r square from here to the other side. And how do we do that? Since these both are multiplying this, so we are going to apply the inverse of multiplication, which is division. So we are going to divide both sides by pi squared r squared. So we are going to have a squared all over pi squared r squared equals to pi squared r squared bracket h squared plus r bracket close all over pi squared r squared. Okay, so having done that, what do we do next? Pi squared r squared is going to cancel out each other, so we are going to have this cancel out this, left with a squared all over pi squared r squared equals to h squared plus r. Okay, then remember we are making h the sorted formula, so the next thing is to take this over here by using the inverse operation of addition, which is subtraction. We are going to subtract both sides from r, so a squared all over pi squared r squared minus r equals to h squared plus r minus r. Of course, r minus r will give you 0, so we have a squared all over pi squared r squared minus r equals to h squared. Okay, so the next step, for us to subtract these two, we have to find the LCM. So the LCM of this fraction will be pi squared r squared. Okay, so I know some of us may have problems with LCM. We are going to treat on that, but let's just go ahead, and we are going to have a squared minus, and this pi squared r squared will multiply r, so we are going to have pi squared r squared times r equals to h squared. We can now go further and saying a squared minus pi squared, these are like terms, so we are going to have r cubed or r raised to power 3 all over pi 2 raised to power 2 and r raised to power 2 equals to h squared. Now remember, we are making h the sort of formula, not h squared, so we are going to see how we can bring this square over to this side. The inverse operation of square is square root, so we square root both sides. We are going to have a squared minus pi squared r cubed pi squared r2 this square root will cancel this square. We're going to have h. Then we can still go further because these two are like terms. This r square can cancel out r square here, so we're going to have a square minus pi square. What will remain here should be r, then pi square, because this r2 has been cancelled here. So we have this. So this can be written as h equals to a squared minus pi squared r all over pi squared. So we've been able to make h the subject of the formula. Okay, we are going to go to the method 2 for making h the subject of this formula. Okay, so first of all, again, our problem is to simplify the equation by taking this square root to this side, and the inverse of square root is square. So we square both sides, which we have already done before. Bracket, bracket close, square. Remove the bracket, we have a squared, and once we square this, we have pi square r square, and put these two in bracket. This square will cancel the square roots. Okay, this is where we are. So another method of doing this is to open the bracket. Remember that this pi squared and r squared are going to multiply these two terms. So we can decide to open the bracket. When we open the bracket, pi squared r squared multiply h squared to give us pi squared r squared h squared. And also, it will also multiply this to give us plus pi squared r squared times r. Okay, so let's do that. So we have pi squared r squared h squared plus pi squared. These are like terms, so we have r raised to power 3. Okay, now remember, our focus is to make h the subject of formula. We can decide to remove this pi squared r cubed to this side to make it simpler. The inverse of addition is subtraction, so we are going to subtract both sides with pi squared r cubed. So we have a squared minus pi squared r cubed equals to pi squared r squared h squared plus pi squared r cubed minus pi squared r cubed. Of course, this will go because it will give you 0. So we have a squared minus pi squared r cubed equals to pi squared r squared h squared. So we are going to have a squared minus pi squared r cubed equals to pi squared r squared h2. Remember, we want to make h the subject of formula, so we see how we can push this pi and r to this other side since they are multiplying h. So we have to find the inverse of multiplication, which is division. So we're going to divide both sides by pi squared r squared, pi squared r squared. So this will cancel this, and this will cancel this, and we have a squared minus pi squared r cubed all over pi squared r2 equals to h2. Okay, now how do we remove this square? We are going to find the inverse of square, which is square root. So we're going to square root both sides. So we have the square root of a squared minus pi squared r cubed all over pi squared r squared equals to square root of h squared. So this square root will cancel this square, so we have square root of a squared minus pi squared r cubed all over pi squared r squared equals to h. Okay, so this can also be written as h equals to square root a squared minus pi squared r cube all over pi squared r squared. To simplify it more, since these two are like numbers, so we can divide them. So we're going to have h equals to square root a squared minus pi squared. What will remain here will be r all over pi squared. So we have been able to make h the subject of the formula.
Try the following problems. Make the variable highlighted green the subject of formula. Our next topic shall be expression of numbers in standard form.